If we have no iPad, reconnecting. Okay, it says reconnecting. It did it the last time. Come on, you can do it. Timed out, reconnect. Maybe we have to start again. Luckily, we didn't get far. So somebody needs to answer this while I'm reconnecting. If the lines are independent, inconsistent, no solution, what do we know about those lines? They are parallel. Open. They are parallel. And don't you forget it. What is CIO again? Okay, here we are. Okay, so in 3.1 we graphed and looked at the problems we plugged in. Here we go. There are three choices that we can get. We can either have one solution where the lines intersect, and that is when the system is CIO, consistent, independent, one solution. Inconsistent, independent systems are parallel. They do not intersect. They have no solution. And then we can do the math is when the lines coincide, and basically they may look different, the both equations, but it's the same line. So if you weren't here, look at the notes again. We talked about this. We talked about here. We graphed some from the book, CIO. Here we had a CDM. We graphed them. We talked about true or false problems, and that was it in 3.1. And I think we did one problem, substitution method. Substitution method is we can only solve an equation with one variable. So what we have to do is we have to substitute one equation into the other. Don't do it into the same equation, because then you're going in circles. Not a good idea. Now here are the steps, and I think we did this one problem. The first step is, if it's not already happening, you must isolate one of the equations that either says x equals or y equals. You have to do that. And we had to do this with the purple problem. We changed the second equation and we solved for x. We solved for x, so then step 2 is we're substituting the equation from step 1 into the other equation. This is important. Sometimes students put it in the same equation and then nothing is happening. It's like you're going in circles. So you got this red equation had to go in the first purple equation. Then we had one variable, we solved for y, we got -4. Then step 4 is substitute the answer from step 3 into the equation from step 1, which is the red one. That's the easiest way to do it. Write the solution as an ordered pair if possible, and the 6th step could be check. I don't check enough, but you can always check yourself and see if you have the correct solution by plugging in the ordered pair for your x and y and see if they work out. Okay, so let's practice some more today. Are you ready? Okay, let me pick one from the book. How about number 15? Why not? 15 on page 209 is x minus y equals 8 and 3x plus 2y equals 9. Now this problem I probably wouldn't do substitution method, but that's not the point right now. The point is to practice substitution. So here we have to solve. Use substitution method. Neither one of those two equations says x or y equals. So A, which one do you think is the easier one to rearrange? And B, for which variable? One of the equation has to look like x or y equals. So we have to isolate here first. Tony Ann said she would do the second equation, and you would want to solve for which variable? X or Y, it's totally up to you. Okay, let's just do that. Michael, hold on your thought there for a second. Tony Ann here said she wants to isolate the second equation and solve for y, right? Is that what you said? Yeah. Okay, which means you would have to subtract the 3x. You get 2y equals negative 3x plus 9. Guys, if you have a different idea, start typing it. And then we would divide by 2, and we get y equals negative 3/2 x plus 9/2. Okay, we isolated the y, and now we're plugging this into the first equation, and we get x minus negative 3/2 x plus 9/2 equals 8. And I know how much you like fractions. Tony Ann, this is the way harder way to do that. I do not recommend it. I'm about to erase it again.
I'm sorry.
No, that's okay. No, I wanted to show that because I'm sure you weren't the only one. You do not want to pick the equation where you end up with fractions and all kinds of stuff that could lead to many more mistakes than you want to make. I actually had a student once many years ago. He always did that. He just, I said, what are you doing? And then it was always wrong. I'm like, look, this can be done way easier. No, that's the only way I know it. I said, well, okay, then do it your way, but make sure that you know how to work with your fractions. So I'm going to erase that is a way to do it. And for me, it wouldn't bother me if I work with fractions, but I know you probably, maybe not so much. Okay, what you always want to look for if you have to isolate or rearrange an equation is to look for the variable that is by itself. In other words, has an invisible 1 in front of it that you don't see, but it's there. So I hope I didn't, now I lost it again because every time I add somebody in, it's going away. It hasn't done that before. It's, I don't know, I have to call IT and find out why it's doing this. So we have to reconnect. What does that mean? That means just everybody has to come in at the same time. Here we are. Okay, back to our problem. Okay, so you want to look out for the variables that are by itself. So Michael says subtract x from the first equation. Okay, let me write the, bless you, let me write the first equation down. So Michael said subtract x, and what you get is a negative y equals negative x plus 8. Now, Michael, that also would not be the way I would want to go about this. Why not? Because here's another step. I end up with a negative y equals.
Can't you divide by -1?
Yes, I could. So that would be a plus x minus 8.
And then for the 2y?
Yes, I could do that, but now I did an extra step. We're mathematicians and we don't want to do that work. So the easiest way, I just want to show you the easiest way. The easiest way for this one problem is solve for x. Bring the y over to the other side. So x minus y equals 8, add y, guess what? Done you are. X equals y plus 8, and you're replacing the x in the second equation. So here was just one step of rearranging. With the negative in front of it, I needed 2 steps. One step, let me write it down. Not that this is wrong, it's just a little bit more work and one more way to make mistakes on a test. Because I've been doing this a long time. You students forget, oh, there's a negative there. Oh, I just disregarded. Or if there is a negative, you have to plug in, make it all negative. So be careful about that. You got to get an eye, or you got to train yourself to see what is the easiest way I can rearrange here. And the easiest way is to solve for x. Y is negative, right, Michael? So that makes it a 2-step rearranging. We're going to go in here now. 3 times y plus 8 plus 2y equals 9. And that is the equation I want to solve. 3y plus distribute the 3, 24 plus 2y equals 9. 3 and 2 is 5y, and subtract a 24. What's 9 minus 24? Negative 15. Divide by 5. Y is equal to negative 3. Jackie, I think you have your microphone on. Because you were
Sorry about that. Sorry about that.
Okay, no, that's all right. Y equals negative 3. What do we do with this information? Now we're going to plug this in into the one we rearranged and get x. X equals negative 3 plus 8. X is equal to 5. So our ordered pair is 5 comma negative 3. Now, just to show you real quick in a different color, how about purple? In purple, I'm going to show you what happens that we get the same answer if we're replacing the y. So that would be 3x plus 2 times x minus 8 equals 9. 3x plus 2x minus 2 times 8 is what? 16 equals 9. 3 and 2 is 5x. And we add 16 to both sides. 5x equals 25. Divide by 5. X is equal to 5. You see, we get the same answer. We better get the same answer. You have to get the same answer. It doesn't matter which one you rearrange. Even with the fractions that we saw earlier, we would have gotten the same answer if we do it correctly. But this was just the quicker way of going about it. What kind of system is this? IINS can't do the math, or CIO? What is this? This would be a CIO. You are correct, Danielle, CIO, because we got one solution. Okay, yes, Tony Ann has a question.
How did we get the x value?
How did we get the x value? Once we had y, that's -3, we plugged it into the equation that we rearranged into this one right here. X equals y was -3 plus 8.
Okay.
-3 plus 8 is 5. Okay, here's one for you guys. Ooh, maybe not. How about 22? X plus 2y equals 0. 2x minus 6y equals -15. Okay, I'll give you a minute. This one's for you. We have to do a fraction one too. Sure, why not? What you will not see me do is a decimal one. I'm not a fan of decimals. There will be no decimals on the test. Okay, 22. Go ahead and solve. Now, there's really only one way you want to rearrange this. The easy way, right? One of the equations has to be rearranged. Now, can I ask you a question? Y equals x. First of all, that's the wrong sum. X equals -2y. Right? Yeah, because that's only 2y to the other side. And then, why do you make it hard on you with the fraction? Just leave it x equals -2y. Plug it in.
I think I absolutely.
Yeah, you did. I know. You made it hard on you. Maybe it's because you want y to be equal. You got all kinds of pens. Use them. Yeah. Oh, I like the blue. They're pink. Fraction action. Okay, your answer can be a fraction. There's nothing wrong with that. People online, type in your answer. What did you get? Okay, no idea. Let's see what online, what do we have? Okay, we got one answer. Come on. Are you all sleeping or you're eating lunch or what are you doing? You're at the beach. Anybody else an answer? Okay, Elijah, where the negative is, doesn't really matter. Danielle has a -3 and you have a -2. So let's take a look. What you want to rearrange is the top one. And you want to say x equals -2y, right? That is the easiest one to rearrange. Anything else is giving you headaches and more work than you have to. Right? Right. Yeah. Right. Yeah. So you go ahead and you replace this x with negative 2y. Minus 6y equals negative 15. So multiply the 2, you get negative 4y minus 6y equals negative 15. Combine the like terms, that would be negative 10y is negative 15. And then you're stopping because you think there cannot be an answer. What is this? We have a fraction here. There's nothing wrong with a fraction as an answer. If you reduce it by 5, you get positive 3/2. And you guys have negative 3/2. Did I do this wrong? Anybody else positive 3/2? Yep. So then I'm going to plug it in. X equals negative 2 times 3/2. I can reduce the 2's and x equals a negative 3. Oh, yeah. Okay, so you had the signs switched. So the answer is negative 3/3/2. Didn't realize it was negative 15. Oh, I see. Yep. Cool. So be careful what it is that you need to do. Practice, you need to do about 1,000 of them. No, maybe 100. Okay, next one. This one's for you again. I'm going to stay out of it. Number 23 in the book says 2x minus 6y equals negative 2. X equals 3y minus 1. This one's for you. Nice and easy, it's so the commercial says. It's already set up for you. No rearranging, we don't have to isolate here. You can just go ahead and literally plug it in, like the commercial says. Plug it in, plug it in. Plug it in, plug it in. I guess I'm wearing this color today. Might as well use this color. What's going on here? Anything strange going on with this problem? We have 2. X is being replaced with 3y minus 1 minus 6y equals negative 2. Is so far everybody with me? Okay. Okay, let's do distributive property. 2 times 3 is 6y minus 2 minus 6y equals negative 2. Okay, what's going on here? I have 6 strawberries and I eat them. There's nothing there anymore. So the y's cancel out. And what you have left is negative 2 equals negative 2. Well, that's true, right? Negative 2 equals negative 2. That would be an identity. And when you have an identity, what kind of system do we have here? Remember, we have 3 types of solutions that we can have. Not just the CIO. What is this? Is this an IINS or is this an can do the math? What can we do? Nothing, yes we can. We can do the math here, that is the CDM. So if your variables cancel each other out, and don't say 6y minus 6y is y. That's not true. 6 strawberries minus 6 strawberries, there are 0 strawberries there. And 0 strawberries or 0y is really the same as 0. Nothing there anymore. But in this case, the left-hand side is equal to the right-hand side. That's an identity. That means in terms of solution, we have infinitely many solutions. And if we were to graph this, it would have been one line. I don't want to graph it. So be careful. Sometimes your variables can cancel out, and then you think you're doing something wrong. Go ahead and ask me.
Oh, don't we combine these now?
Yes, 6y minus 6y, they cancel out. No, they cancel. They're gone. They cancel each other out. Cross them out. Cross them out. Here you go. Put it in left. -2 equals -2. So be careful. Don't think you're doing something wrong. Oh, I have to have a variable. No, you don't. You do not need to have a variable because we have 3 different types of answers. Let's do another one. Okay, people, I'm coming. Next one. Let's see what we got here. Number 28. Let's try 28. 28 is x plus 4y equals 8, and 3x equals 3 minus 12y. Here you have to isolate. Go ahead. Then we do a fraction, and then we go to addition method. What time is it? Oh, we got time. So on Friday, we're going to finish up addition method and then go into word problems. Isolate you must. Or maybe on Friday I'm going to ask you a couple questions. We can do Kahoot or something. On Friday night, I'm doing a trivia Kahoot. I'm actually running it for, not for students. It should be interesting. Maybe you should test it on you. No, it takes too long. Which one's the easier one to rearrange here? Isolate the first equation or the second equation? The first. Or, Jordan, what did you say? Either way, it really doesn't matter here, but yeah, they're equally easy to rearrange. So if you go with the second one, then you would go ahead and divide everything by 3. And that works nicely here because everything is a multiple of 3. That's why. You can do that, not a mistake, or not wrong, either way. But I'm going to say x equals -4y plus 8. 1, 5 doesn't the other. I don't know what the saying is. In this case, it doesn't matter. Makes absolutely no difference. Okay. But to Jordan's point, if we solve the second one for x, it's less work when we plug it back into the first equation. instead of taking the first equation and plugging it into the second equation. That's a little bit more work. Well, I'm going to go with a little bit more work right now. Minus 4y plus 8 equals 3 minus 12y. Okay, negative 12y plus 24 equals 3 minus 12y. Now, if I move the y's, again, you will see that you get 0 here because they cancel each other out, and you're left with 24 equals 3. What? I don't think so. That's a contradiction. And when you have a contradiction, what do we know about the solution? There is none. So here is no solution. You actually have to write that down. No solution. Or you can just say IINS. This system is independent, inconsistent, no solution. In other words, this means that the lines, if you were to graph this, would be parallel. Okay, everybody online, good? Let's do one last one, and let's do a fraction one. How about number 38? 38 is 8x minus y equals 8, and 1/3 x minus 1 over 24y equals 1/2. So whenever you have a fraction going, the first thing to do is actually to get rid of the denominator. Not the first one, but the second one. The second one, we are clearing the denominator. What is the LCD?
24.
The least common denominator in this case is 24. So the second equation, we're going to multiply everything by 24. Help me out, people online. 24, 24, and 24 over here. You can write it over 1 if you want to. Again, the reason why we do this is to clear the denominator. So what do you have left when you multiply everything by 24?
8.
8x minus 24 goes into 24 once, minus y equals 2 goes into 24. Yes, you are correct. 12. And the first equation is 8x minus y equals 8. Now we're going to learn addition method in a couple minutes. I can already see here what the answer is. But we need to we're doing substitution. We need to rearrange one. So does it matter which one? No, they both have a y here. We're going to take the top one and we're going to subtract 8x. So negative y equals 12 minus 8x. Here you got to be careful. We got to divide by negative 1. Y equals, let me write the x term first, 8x minus 12. This is like a double negative whammy here. We're plugging this into the second equation. It all looks the same, be careful. On the test, there's probably just one problem that will say do substitution, one that will say addition. The rest you can pick whichever one you like better. For this one, I would have done addition method. All I needed to do is multiply everything by -1. I would have been done with the problem. This is a one-step problem. 0 equals 4. I can tell you there's no solution here. But let's work it out. 8x minus, be careful, you have a minus here, and y is 8x minus 12. And I was wrong. Where was I wrong? Where am I plugging it in? Oh no, equals 8. I wasn't wrong. Here you go. 8x minus 8x plus 12 equals 8. So I distribute the negative. The x's cancel out, and I have 12 equals 8 left, which again is a contradiction. And when you have a contradiction, that means there's no solution. How do you like that? Beautiful. I heard that song earlier. IINS. You can do either one. Yeah. If it says here, let's see, what did it say? For systems that do not have one unique solution, also state the number and whether the system is inconsistent or dependent. So if you just write IINS on the homework, that's sufficient. Or can do the math, CDS. Yes, Elijah, IINS. Okay, so that concludes 3.2. Let me see if I have notes for 3.3. I saw something, and I don't know if I want to use them, but we can look at them. 3.3. This is an example again of a graph. That was a CIO, IINS, CDM, and this is substitution. You see, addition method. Here we go. Okay, addition method 3.3.
Wait, can you go back to the last question real quick?
The last problem?
Yeah.
Actually, I can't because I'm in a different folder now. What is it that you need?
I just think I'm really confused with the whole like replacing thing. Because like every time I requested, I just stopped.
Okay, we had, what did we have? We had 8x minus y equals 8, and the other one was 8x minus y equals 24. That's what we had, right? And then I used which one? The first one, and solved for y, right? Did I use the first one? Can't remember now.
Yeah.
Yeah. So 8x minus y equals 8. I subtracted 8x, right? And I got negative y equals 8 minus 8x. And then I divided by -1 everything. Y equals -8 plus 8x. So that's the first equation. This part I have to plug in now into the second equation. Okay? So 8x minus -8 plus 8x equals 24. I think it was the other way around. Doesn't really matter. We distribute the negative plus 8 minus 8x equals 24.
Okay.
You see that? And then the 8x's cancel out. And we're left with 8 equals 24, which makes it no solution. Okay?
Okay.
Look at that again. It is recorded, so you can watch it again. Addition method. Another word for addition method is elimination method. So now, just like the word says, now we have to eliminate one of the variables. Let me give you an example. I guess I'm missing this page. Okay, not a big deal. I can make one up. Let me give you an example of the easiest problem. When you come across addition method, don't worry, you will not have that problem on the test. It's too easy. So for example, we have a system of equation that is 2x plus 3y equals 6. And the other one is 3x minus 3y equals 4. I just so made that up. Addition method or elimination means that now we have to get rid of a variable. We have to eliminate one of the variables. And the only way you can eliminate a variable is if you have a plus 3y and a minus 3y there. So if the setup of your system of equations has opposite variables there already that cancel each other out. And that's where the adding comes from. So we have to eliminate and then we add. And you can clearly see that the y's are already opposite here. Plus 3y on top, minus 3y on the bottom. Life is good. There's really nothing to do with this problem. Nothing needs to be rearranged because now I can just put a line here, and that's where the addition name comes from. Now I'm just going to add those two equations up. Why can I do that? Because one of them is eliminated. So 2x plus 3x is 5x. The y's are gone, and that is equal to 10. How easy was that? Now you can solve for x, divide by 5, and x is equal to 2. A one-stepper problem. Now I have to say I prefer addition method over substitution method, but I think that's just because when I learned this, my teacher back in the day only used addition method for everything. I think he didn't like substitution method, so that's the reason why. X equals 2. Okay, now we got to plug it into one of the two original ones. And again, be smart about it. Try to pick the one that has only positives so you don't have to worry about the sign. So I'm going to go ahead and replace the top x in the first equation with 2. 2 times 2 plus 3y equals 6. 4 plus 3y equals 6. Subtract 4. 3y is equal to 2. Divide by 3. And y is equal to 2/3 in this case. So my ordered pair would be 2, 2/3. And that is the answer. But that only works. We had nothing to do but add. That's the easiest type of addition. Don't worry, you won't. There's one like this in the book. Because most of them don't look like this. Most of them you have to do something. You either have to multiply one or both equations by a number to get opposites here. And that's what we're going to practice. Let's see if there's something. Here is the steps. So you may want to write them down first. I'm going to keep it on this slide for a second. So the first step is when we use addition method, it has to be in the standard form. AX plus BY equals C. It has to be in this form. So all your X and Y's have to be on the left-hand side, and then the number on the right-hand side. If you have fractions, your second step, If you have fractions or decimals, you want to clear them first. Now, I just told you I'm not a fan of decimals. So most of our problems, they may have fractions, but not so much decimals. If you had a decimal, you would have to multiply by 10, 100, and so forth. Fractions are way better. I like fractions. So the third step would be to multiply one or both of the equations by a number to get opposites. That's similar, or keep that in mind, to finding the LCD of both numbers. So we got to multiply and do something. Once we have done that, the fourth step is to add the equations, and we eliminated one of the variables, which means now we can solve the equation. That's the fourth step. The fifth step would be to substitute the answer from step 4 into one of the original equations. And I say original for, oops, I'm on eraser. I say original for a reason, because if you made a mistake in the first 4 steps, then you can catch it with the fifth step. You solve for the other variable, that's other variable, and 7 is check. You always want to check, because if you made a mistake, you can see that there. You will see me sometimes not substituting the answer from 4 into the original one, and that's the case when we have fractions, because it's, I know we did it right, so, but I probably substituted into the rearranged equation. You guys copy that? We got time for one problem, and then we finish this up on Friday and practice some more. Everybody ready? You ready for some more? One more, let's see what we got here. This one here. No. Let me find one. I'm missing some pages here. Let's do this one. 2y equals 5x minus 4. 3x minus 4y equals 1. The first step, remember what it says. Make sure that your equation is in the form ax plus by equals c. Now you can see that this first equation is not in that form. How do we get it there? We're going to have to subtract 5x and write the x first. So my first equation became negative 5x plus 2y equals negative 4. Okay. If we look at both of them, we see that we do not have opposites. So now we need to multiply one or both equations to get opposites. If you look at this example, people online and here as well, which variable do you think is easy? person? You still with me? What are we eliminating, or which one is easier to eliminate? Again, you can stick to one of the variables and use that variable. Elijah said X. Anybody else, any thought? They're all gone. Everybody's gone here. Still there? Okay, I see a thumbs up, but I can't see who that was. Here in the class, the majority said what? Y. And I have to say Y would be the easier one to eliminate. Why is that? With X, you have 3 and 5 here, which means you have to multiply both of the equations by a number. With Y, you have 2 and 4. You also have plus and minus here already, but the least common denominator of 2 and 4 is 4. You already have the first one that is a 4, but the second one is not. So the first one doesn't need to be changed. The second one needs to be multiplied by what? I want to eliminate the y's. We need a 2. So each of these terms has to be multiplied by 2. You get a negative 10x plus 4y equals negative 8. So we're getting rid of the y's because we only had to do one multiplication part. On Friday, we're going to do both of them. I'm just going a little bit fast because I want to get it in all in the time. 3 minus 10 is negative 7x. The y's cancel out. And 1 minus 8 is also negative 7. Divide by negative 7 and x equals 1. Again, you could have gotten rid of x, but then you would need to multiply both of the equations. Now that we know that x is 1, I'm going to plug it into the original first equation. 2y equals 5 times 1 minus 4. 2y equals 1 divided by 2. Y is equal to 1/2. That means your ordered pair is 1, 1/2. This was going a little fast because I wanted to get it done, but we'll continue with this on Friday. Any questions? Anybody? So if you want to take the test tomorrow, that doesn't mean anything what it says there. Go to one of the campuses. I will post this in the announcement so you can see it. What else? Friday, I'm going to show you the test corrections and how to do them. And that's about it. Have a good afternoon. Goodbye, Mark. See you. And tell everybody else to come to class. People who are not here today. It's the end of the recording. Can you hear me? Come to class. Make sure you're here.